Hello, and thank you for joining us here today. We're going to have a roundtable discussion today on solar inverters. I'll be your moderator today. My name is Bill Brooks with Brooks Engineering. I've been working in this field of solar photovoltaics for about 23 years. And we have a distinguished panel of inverter and optimizer panelists that we're going to discuss a little bit about the issues and hopefully provide you with some background about this technology and what makes it work. And so hopefully over the course of this next hour, we'll give you some good, valuable information that can help you in your decision-making processes as you may be interested as a residential or commercial owner of a PV system. So without further ado, what I'd like to do is go around the table here and we'll introduce each one of the panelists and have them give you their name and the company they're with and a little bit about their experience, and then we can get into some of the details. Just to finish out a little bit about myself, I've been in this field, like I said, for about 23 years. Worked with and installed many systems and designed many systems, and I'm a third-party engineer that works with a lot of these companies that we have here today as clients and help them with various issues, work with the National Electrical Code and safety issues. And so hopefully throughout this afternoon we'll give you a chance to see what's going on in this field and give you that background. So I guess what I'll do is I'll pass it off to my left here. And Bates, if you could introduce yourself.
Sure. Thanks, Bill. Yeah, I'm Bates Marshall with SMA America. SMA America is a subsidiary of SMA Solar Technology out of Germany. SMA is a publicly traded company in Germany on the Frankfurt Stock Exchange. SMA is the largest inverter company in the world by far. So in a relatively crowded market with 170 suppliers, we have about 40% market share, plus or minus. Here in the US, we have over 400 employees. We also manufacture our products here in the U.S. as well as a plant in Ontario.
Great.
Hey, my name is Mike Tobin. I'm with Schneider Electric, and Schneider is a global specialist in energy management. We produce products and design products to connect from the utility to the home. My specific job is the Vice President of Engineering and Renewable Energies business, which focuses on photovoltaic inverters. Schneider Electric is 120,000 people, about a 20 billion euro company. We're on the French Stock Exchange.
My name is Bill Rossi. I run marketing for Enphase Energy. My background is really in technology. Prior to Enphase, I worked at Google for 3 years, and then prior to Google, I worked at Cisco for almost 10 years. And so that technology heritage is really involved in the company as well. Enphase Energy was a technology company that was started in 2006. We make a product called the microinverter, so probably a relatively new inverter company on the block, and sell primarily today in the US, but expanding into Europe very soon.
Great.
I'm Clinton Porter, Director of Marketing for Kaco Energy in the United States. Kaco is one of the world's largest manufacturers of photovoltaic inverters, following behind SMA. Here in the United States, we also are producing inverters out of San Jose and most recently in London, Ontario. The company produces photovoltaic grid-tied inverters for the North American market. Our portfolio for the European markets and Asian markets include off-grid and fuel cell inverters, power conditioning devices of all types. So we're excited today to be able to represent some of those technologies for the viewers.
Great, thanks.
Jeff?
I'm Jeff Krissa. I'm with Tigo Energy, which is a 4-year-old company based in the South Bay in Los Gatos, California. Unlike the rest of my colleagues, we are not an inverter company, but make a small electronic footprint that actually integrates with the photovoltaic module that enhances a lot of the work that the inverter does in the balance of system, and we'll talk more about that. We're a 70-person company. We, as I said, are headquartered here, but have a R&D facility in Tel Aviv, Israel, and have commercialized the product about a year ago and are continually ramping volumes throughout the world.
Great. Excellent. Well, you can see we've got a great group of panelists here today, and quite a bit of difference in size of companies, from the very largest companies in the world like Schneider and some smaller startup companies that are exciting to see some of the newer technologies that are coming out. So this is a really good opportunity to kind of see some of the different aspects of this particular technology, and just to kind of give you a little bit of background about inverters without going into a tremendous amount of detail. The term inverter is basically somewhat of a amalgamation of a couple of different terms. Power converters are probably a more generic term, and the term inverter has to do with the fact that we have some type of a source, typically a DC source, that we're having to transform and convert into a source that we can use in normal household appliances and things like that. So in the normal world, we have AC appliances, what we plug into the wall, alternating current rather than direct current. And this goes back in history to a fight between Westinghouse and Edison, and Westinghouse won the fight, and the rest is somewhat history. So, but without getting into the details of that, we do have a DC converter technology here, and so again, kind of going along with that same motif of a power conversion device, whether you're converting from one DC form to another DC form or from DC to AC, ultimately what we're talking about is being able to utilize the electricity from a solar photovoltaic module or array and be able to have a generic application of that technology in our homes and our businesses. And so that's really the foundation. They're a critical part of the process. Without power conversion devices, it's very, very difficult to use this technology. And so, these technologies that we're dealing with here are as I say, play a critical role. The technology of inverters has been around for decades, and so this is not a new technology. How we use it may be new, and certainly there's a lot of newer technologies being implemented. But the earliest photovoltaic inverters that go back to grid connection actually happened in the late 70s. And so they've been around for quite a long time. And in fact, one of my colleagues here is from Schneider. They purchased a company called American Power Conversion, and they were one of the very first solar photovoltaic inverters in the world in the early 1980s. And so that company went on to make UPSs for household computers, and many of you have those types of inverters in your house today. So the little UPS boxes that you go down to the store and purchase to give you surge protection as well as protection in the case of a utility outage are very similar technology to what we're talking about here in the solar photovoltaic world. So that's just a little bit of background, and I would like to kind of put it out to, since we do have a lot of different experience here and different levels of where these technologies are being used, maybe give the panel a chance to talk about the products that they have and kind of where they've come through the process of building inverters for the PV market. So who wants to jump into that?
I guess I can start.
Sure.
So Enphase Energy we make a product called the microinverter. So it's a small inverter, and it's typically utilized today for residential applications or small commercial applications. So that can range, typical residential might be smaller than 10 kW, which would be 25 or 30 panels. A small commercial installation might be as high as 100 kW, so it could be 200 to 300 panels. The microinverter is probably one of the newer technologies on the scene, and the main difference between a microinverter and a traditional central inverter is that we're converting energy at the individual panel itself instead of at the individual string. The advantage of that approach is you tend to get more energy out of each panel when you're converting at the individual panel versus the string. The other benefit is that the the technology incorporates communication directly in the microinverter, so the system owner or the installer can actually visualize the amount of energy being produced from the solar array. So if there's any issue with the array, bad module, or it could be some people just like to visualize the energy being produced on a sunny day. So you get that via standard mobile handset with a browser or a PC. I think the solar installers like the product because it's relatively easy to install because it's all AC.
Schneider, you have quite a variety of products, so tell us a little bit about.
Okay. Unlike the microinverter, we make typically for residential applications is a string inverter. So rather than having an inverter at each module, we have one inverter down at really at your electrical distribution panel within your house. And all of the solar panels will be connected down to that one inverter. That's string for residential. We also have what we call central inverters for bigger applications such as commercial rooftops. So these are systems first in the residential were typically 2 through 6 kilowatt type of sizes. As we go into commercial rooftops, we rise to 30 kilowatt, 100 kilowatt, up to 500 kilowatt machines that are 3-phase rather than single phase. One thing is a little bit different regarding most inverters that we look at, and maybe not everybody understands in the market in residential, is that when we have a solar inverter, if the utility power goes down, we lose our power even though the sun's shining, because our inverters, the grid tie inverters, don't do any type of voltage control. So if the utility goes down, we immediately have to turn ourselves off. So that's the typical application for grid tie inverters. We also have some other systems that are called backup power, as well as off-grid. So some off-grid, if you have an island or some cabin in the woods, we can give you a product that allows you to tie the solar your solar modules down to your house to connect that one and give yourself power there. On the backup power, we have the same type of system, but on a bigger scale, running from 2 to 6 kilowatts that allow you to connect the solar panels plus any type of wind applications or wind turbines into a DC bus and then into our Xantrex XW inverter and then back out to the grid. So those type of systems allow you to maintain power even if the utility goes down. So I think that's kind of the main differences between the grid tie and backup power type of systems that we have, the residential to the more commercial sizes.
I can jump in here too. Kaco is very similar to Schneider in that context. We manufacture grid-tied photovoltaic inverters from 1.5 to a megawatt station, which we're also involved with single-phase for residential applications up to now 8 kW and into 30, 50, 100, 500, and most recently we're working on the build-out of a larger station for utility-scale connections in the 3-phase, but focusing on transformerless technologies, which provide for a less expensive, lighter weight, usually easier to install product that we're excited for in the US specifically because it is fairly new for the installation, for the installers of the markets here. Been working very hard to talk with folks about how they can work with these systems and dealing with grounding issues that arise. I know that you're very familiar with this as well, Bill, and the integration of maximization technologies into those transformerless units makes for, we think, a very clever answer to the launch of microinverters and other DC to AC conversion technologies that folks are implementing onto the roofs. So that's really like our breadth of products for the United States market and for North America in general. We'll see that built out especially over the course of the next 2 quarters.
So Jeff, you guys, Tigo and Kaco, have some agreements been working together for a while. How does your product fit into their products?
Well, if you look at the photovoltaic plant early on, basically you had modules and you had an inverter. And the inverter helped you take the DC energy from the module and put it on the grid or put it into AC so it could be utilized. And that was your basic PV system. Nowadays, PV is becoming an asset. It's more of an investment vehicle. It's something that either for your home, you'll go ahead and put on your roof to lower your energy bills, or if you're a business or in the power plant business, you're trying to create energy for cheaper than the power company can elsewise. So really the focus today is to be able to manage that asset throughout its life cycle in a way that's much more detailed than it was 20 years ago. And so I think what we call balance of system, or the environment we all play in, is much more than just inverting DC to AC. It's really become how an individual manages their asset, those solar panels that are sitting out on your roof. So of course inversion and getting that energy to where it needs to go, either onto the grid, into the battery, into your EV, into your home is critical. And that's really the core function of any one of our products. But you know, equally as critical is optimizing the output of those solar panels, making sure all of that energy can get into where you want it to go so you can get the most money for it. Being able to visualize what's happening on the roof down to the panel level. If a panel's broken, if a squirrel chewed your line, if a diode blew up, you want to know that so you can fix it. And then certainly you want to have the safest environment possible to be able to make sure that any high voltage is able to be turned off and what you have on your roof is conducive to safety in the home. So what we've done is we've actually created a small set of power electronics that goes onto the solar module and makes the module smarter so that the inverter now has a control and access to that module that it's never had before, so that the inverter can be smarter in the way it manages the PV system. So we work quite closely with inverter manufacturers, such as Kaco, to be able to make sure that the inverter can utilize the control and communications now available at the modules to do a whole array of different kinds of functions. And that's the nature of our interworkings with the inverter industry and Kaco in particular.
Great. Well, SMA is the largest photovoltaic inverter manufacturer in the world, for sure. And you have quite a variety of products. Tell us a little bit about the breadth of products and maybe what you're looking at even in the near future.
Yeah, so I think SMA is unique amongst inverter manufacturers in that we have a range of products that range from central inverters, string inverters, all the way down to our forthcoming microinverter product. So we cover all power ranges, all module technologies, and we're active in all markets worldwide. I would say our product strategy is informed by the key issue in PV of our time, which is the economics. Anybody who looks at solar, even from time to time, understands that solar has a cost issue. It is a market, a technology that's supported by government incentives in every active market in the world. So I think those of us who pay attention to the incentive programs realize that these incentive programs will not be there forever, especially in these economic times and the budget crunches worldwide. So we are singularly focused on cost reduction through the development of system technology. So if you look at the 30-year history of our company, what you see is that we have a track record of year-over-year system cost reductions. And this is a key point because we're not just focused on slashing the price of the inverter year over year like you might see happening in the module world, but actually technological innovation that would drive the entire system cost down. So that's our strategy, is to lead with technology, but technology focused specifically on system cost reduction.
Great. So what we've heard about here today is really talking about very different sizes of systems, sizes of inverters, from the panel level or module level. We're talking about something in the 200 watt range, very, very small, up to 500 kilowatts, 500,000 watts, or even larger. And so we have an enormous range of products out there. And so each one of these companies, obviously, some of them have focused on a singular one of those size ranges, like the microinverter size, and others have a broad range. And so I guess getting into the details of that, when somebody is considering purchasing a system or a product, what would you say is kind of the main reason that you would recommend a micro inverter product or a string inverter product or a large central type of a product? Obviously, they're all manufactured, and some companies manufacture all three, so there's got to be value to them. one isn't necessarily a clear winner of the other. So when would one make sense and when another make more sense? Anybody?
I think initially for microinverters, they were used to overcome issues on the roof. It could be shade from a tree or a chimney or a telephone pole. So oftentimes, to get the most energy out of the system, you needed to have that individual PV module inversion. I think as the industry has developed, that tends to be less the case now. I think more and more we're seeing microinverters going into standard situations with little or no shade. I think the factors that are driving that, I think, are two things. One, the reliability. They don't suffer from a single point of failure. You have multiple microinverters on a roof, so if any one microinverter were to fail, the system is still running at 98 or 99% availability. So that's probably the primary reason. I think the secondary reason is the visibility that they get because the communications and networking is built directly into the microinverter. The installer or the system owner can see what's going on a real-time basis. So if anything were to happen with the array, they could address it very, very quickly. Oftentimes, I think with string or central inverters, although they have monitoring, lots of residential and small commercial system owners don't end up deploying it. So oftentimes, if you have an issue, it can go unrecognized for days, weeks, at least until you get your next utility bill.
Yeah, I would just jump in, Bill, and say that the answer really varies by segment. And even though at the end of the day, PV is all about maximizing energy at the lowest cost, the way those specific math works out is quite different if you're an individual homeowner with a single-family home or if you are a utility-scale developer building a ground-mount plant in the desert. So the issues of performance and cost are always there. Even within that segmentation, SMA has at least a couple of different architectures or topologies to offer. And then the variation really comes down to what's the customer's business model and how do they intend to go forward with the project, how is it going to be financed. But everything is always in mind with energy generation and keeping it down the initial price, but also the ongoing operations and maintenance pricing.
I think as you pointed out, Bates, about the system cost being the most important thing, and if my understanding on the microinverters, typically it's a more expensive, it has some other features, but it's a typically more expensive installation. So from a central or string inverter, it gives us the ability to have everything at one spot. It's a lower cost, but even for a system reliability, there's things of where you have to have multiple inverters on a rooftop for the microinverter versus one point of failure on a string inverter combination.
Well, I think it's important also to mention that the type of incentive that's being delivered to the consumer is important when factoring the cost of the energy. Obviously, if it's a performance-based incentive where kilowatt-hour performance is of utmost importance, it's going to be a different situation than if they're receiving an upfront incentive. And a homeowner that has a 3 kW system maybe doesn't necessarily want to have always panel level visibility, or the installer may not want that. They could potentially just prefer a cheaper solution that is accessible via a monitoring solution offered from a string inverter. That being said, there are other ways to maximize performance in the DC to DC maximization and topographical enhancements of the inverter and installation procedures. How easy the inverter is to install can affect the labor costs, sometimes substantially.
Sure. Our view is that the microinverter has brought some very, very nice features and light to some very nice features. But those features being offered to the homeowner are equally, we believe they're equally as important to somebody running a multi-megawatt station. You still want to make sure your assets are functioning. You still want to make sure they're safe and producing the most energy possible. That's not something that should be reserved for a 4 kilowatt residential application. Although right now the cost dynamics of it tend to slot it towards smaller installations. What we have done is we've taken some very, very minimalistic, very low cost electronics and put them out at the module, so the module's more intelligent. And therefore, while interacting with inverters of any size, be it a megawatt station, be it a 100K commercial type inverter, we can still deliver all that value that the homeowner has enjoyed from a microinverter to the megawatt station while keeping the the economics of a centralized or very large inverter. And in the end, as Bates said, it's critical that each individual systems designer can pick the right product for their application. And that's why we think that the array of inverters that are available to the market now is appropriate in that they're able to choose any given capacity, size, AC modulation techniques for their applications.
Well, there's interest, Bill. You were saying how the inverter has been around for about 50 years or so, but it's really a new application of the inverter. As we look at today with our inverter, they're continuing to change. So there's, right now you could say you'd rather have the micro or the string inverter, but as we move along, we're trying to figure out better ways from a system, how to create systems, how to make them safer, more efficient, and really all the groups are working together with UL and standards to try to understand that. So we're gonna, as we look at today, things are going to be changing even tomorrow and next year to make sure we have inverters changing. So we'll be all changing relative to what those market requirements are.
Yeah, I think that's a very good point. This is such a fast changing market, such a fast growing market, that to say that any one of these technologies is going to win the day is really maybe an inaccurate statement, because the fact is that there are so many, it's a very dynamic scenario. And so, obviously large companies are looking at the entire spectrum. They're not saying, well, these are the only inverters we're going to make. And when SMA first came to the US, they manufactured a string inverter. And they told everybody that central inverters really were not as good as string inverters, so they made their case for the string inverter. But now they make central inverters, and they're probably one of the biggest suppliers in Europe of string inverters, and making a pretty good dent in the US market. So you can never say never. It's a market that is constantly changing. And then maybe Bill could speak to the situation of Enphase is taking a huge part of the market segment of the residential market in the United States. How does that happen? How did that happen? You've only been a company for how many years, and now you're knocking on the door of being the #2 supplier in the United States.
Yeah, the company was started in 2006. So 2006, 2 years later, started shipping products. So in 2008 was when we first shipped our first microinverter, and roughly 2.5 to 3 years later, we're well over 500,000, approaching 750,000 microinverters, with about 20% of the market in California, which puts us probably a clear #2. I think in the U.S. market, especially in California, installers I think are generally open to new technologies, and so it was a great place for us to kind of plant our roots. And I think just the microinverter value proposition, right? The fact that it can deliver more energy, so it will come at a higher upfront cost. It tends to be anywhere from 20 to 40% in terms of, if you look at just the pure inverter price. But the inverter only represents about 10% of the overall system cost. So on a system basis, the actual cost increase isn't that dramatic, and the fact that it's pulling out 5 to 10% more energy, usually justifies the upfront cost. So the installer has to make that pitch to the system owner.
Sure.
System owner has to be willing to say, I'll sacrifice some of my upfront dollars, knowing that I'm going to get more energy over the long run. So I think that has been the real strength of our offering, the fact that we get more energy and we can do the monitoring.
Let's talk about cost for a minute, because Bates brought that up, and I think it's a great point. Now, obviously, cost ultimately at the end of the day is what matters.
I would have to say something like $1 per kilowatt hour metric, which would take into account both the acquisition price as well as the long-term service and maintenance costs, as well as the energy production. There are those who lean on LCOE, levelized cost of energy, but typically those types of analyses take into account things which are significantly out of an inverter company's scope of supply, like the cost of land and the cost of capital. So we would typically lean on $1 per kilowatt or megawatt hour.
So energy, how much it costs for the energy.
I think I still have along the same lines. We have to look at the dollars per watt, but the target has to be towards the grid parity, as we say. So it's where it doesn't need any external or government funding. So that's the driver, is what cost do we have to get to where we don't require any government funding anywhere in the world. And so that's kind of the target. because that's where the wind industry is kind of really already there, but they got there through a lot of government funding, so we still need that government funding to help us get there. From an overall system cost, there's a lot of different components within there. With Schneider Electric, we're working across the whole gamut, so from the switches, so the DC switches, across the inverter, across all the connection points. We're working all those areas trying to bring the cost down.
I would agree, dollars per watt. I think the challenge in residential installations is, the customer tends to be very focused on the upfront cost of the system, because they don't know, sometimes they don't know if they're going to be in their house 5, 10, or 20 years. So we try to get them focused on the overall cost of the energy being produced, or the value of the energy being produced. That's more effective, I think, in commercial installations where they understand that.
Right.
Residential, it's been, for us anyway, it's been an education process.
Sure. Absolutely.
I think, Bates, you said something interesting too, $1 per kilowatt hour, which is something we talk a lot about, because most of the installers that we'll talk to, or project developers, will reference that dollar per watt number.
Yes.
When in the background of coming from a tariff environment where folks are receiving payments per kilowatt hour, they really do look at how much energy is produced by their system rather than how much the upfront capital costs are. And so that difference between dollar per watt and dollar per kilowatt hour is interesting. I think that I'd like to see it move towards a dollar per kilowatt hour conversation, because we can talk more about how much energy you're actually producing, and the commodity you're providing, electricity, is maximized. But that being said, the reality on the ground still seems to be that most folks will talk to us, and what we focus on is reducing that dollar per watt number. So that
Yeah, I'm sorry, I didn't mean to cut you
No,
off,
it's
but
fine.
I would just add that I think again, the economic considerations to me are near the top of the list, because if this was a era of easier credit, your average homeowner, your average commercial enterprise could easily go out to the bank and get bank financing for something that's going to pay off on a 30-year term. The reason there's such a focus on acquisition price is because for the residential market, these people are writing big checks or otherwise having to finance these systems themselves. So
before I came to Kaco, I worked at an installation company in Southern California and just sold installs to the homeowner, and that was the bottom line for folks was, well, how much does it cost? That's all they really wanted to know. When it came to reliability and features and monitoring and all the other stuff that we care about as educated solar people, they didn't care about that as much. They really wanted to know how much it cost.
In the end, it's kind of that cost of ownership.
Right. How much does the check need to
If
be?
you could tie that cost of ownership over the years, and we're going to talk about warranty also, but how long is that system going to last? If that system's only going to last 5 years or 10 years, then you got a problem you're going to get back and replace, so your time value of money, your net present value is hurt. If the product's going to last for 15, 20 years, or it's easy to service, those are things that help to reduce the overall cost of ownership.
Well, it's interesting at the homeowner level too. I mean, how many appliances do you have in your house that have been there for 20 years? Not many. I mean, I go up to my mom's house, I don't see anything that's there for 20 years except almost the washing machine, and it needs to be replaced. I mean, there's nothing really out there. I mean, cars maybe. There's not much out there that's warranted for 10 years or that has to be installed and then used for 20 years on the consumer level. So it's an interesting value proposition to put forth to a homeowner, someone under 10 kW who has really no idea. They're balancing out a countertop versus a solar installation. They don't really think about that.
Some of our bigger systems, we do look at service contracts. So today we look at our warranties of standard is 5-year. In California require a 10-year warranty. But we have commercial customers that require to have 20-year service contracts, so they can look at that cost right now. So there we look at the parts that have to be replaced at the intervals of 5-year or 10-year or 20-year to make those products last that long.
Well, I guess that's the answer to your question, though, is I still find it to be, across the spectrum of the North American market, to be dollar per watt for us, and really reducing that as the most important consideration for us currently, with an eye on that dollar per kilowatt hour number.
There's just no departing from the CapEx equation, right? Because even when you can sell reduced kilowatt hours, there's still the homeowner, for example, is getting 4 bids and will generally choose the lowest bid. So, being able to have a cost-effective roadmap. I mean, we're in an environment where we're looking at the balance of system, but perhaps the larger chunk of the cost is actually in the photovoltaic material, which is dropping like a rock. And so, the overall cost of installing solar unincentivized is coming down quite significantly. Right. And so the balance of system as a percentage of that needs to stay in and about the same percentage, or we're going to wind up being the largest portion of that. If you look at what the federal government, the U.S. federal government is doing now, this Sunshot program that was recently brought out by the DOE is not a kilowatt per hour or dollar per kilowatt hour. It's $1 per watt. Get it down to $1 per watt. And I think that's what we've all rolled up our sleeves and taken a commitment to work towards in that vein.
Well, it brings up an interesting point because I work in the area of codes and standards quite a bit, and so work on the National Electrical Code Committee and also on the standards that that inverters have to be certified to. And the challenge is that we have a situation where if you drive the cost down too far, you could run into a situation where we now have reliability issues. When we say a term like dollars per kilowatt hour, or dollar per amount of energy that's produced, that's a hard thing for a customer to really understand or kind of internalize. And working with the California Energy Commission, I oversee the list of inverters for the state of California. And one of the things that we try to do very early on and have made steps to improve that process is to set some basic requirements for inverters so that the minimum standard is not too low. And because clearly we can build inverters cheaper and cheaper, but at some point they won't work very reliably. So if you turn the clock back and look 10 years ago, what was the main thing that you wanted out of an inverter? It was reliability. Because the second an inverter shuts down, doesn't matter how efficient it was, doesn't matter the bells and whistles it had, doesn't matter any of that stuff. The fact is you've got a solar array up on your roof that's doing absolutely nothing. And so those are really very important issues that from an educational point of view, and one of the purposes of this roundtable is really education, is that certainly understanding and making sure that not only are these things efficient, do they have the proper features that you need and things like that to let you know when there's something wrong, but they're actually reliable, and they're going to be reliable for whatever period of time you need them to be reliable for. And how would they be upgraded into the future? All those kinds of things are really critical consumer issues, whether you're talking about microinverters or you're talking about station level electronics. When we start talking about warranty, that's an area that consumers can have some interaction with the company on and understand a little bit about that. The state of California requires a 10-year warranty. That's a huge warranty for a piece of electronics, quite frankly.
Doesn't exist.
Exactly. And if you look at other electronics, it's just not out there. It's just that was a requirement for selling into the state of California. And I guess one of the questions is, how in the world do you get to a 10-year warranty, and what kind of assumptions do you have to put into that, and what should a consumer be looking for when they're purchasing a product in warranty?
So I'd say we look at purchasing a warranty, the important thing is that at the end of 10 years, your company's still around. So one for Schneider Electric, we've been around for 175 years or so. So we got a good chance of being here in another 10 years. So that's probably the most important thing, is that we'll still be here and that company stands behind it as we do. For us, we don't want to pay warranty. So we want to make sure that the products last for those 10 years. So a lot of things we brought first, our company from Schneider Electric, we had purchased a company called Xantrex, and that was purchased in the end of 2008. So Xantrex had lots of experience in photovoltaic world. Schneider has lots of experience, one of the biggest inverter manufacturers in the world from the APC and from the drives manufacturer. So what we do is we take all the experience we have within Schneider and try to apply certain design standards to say, this is how you're supposed to design an inverter to last for this many years. So the things we try to do to that during the development cycle is put it through some really robust testing. So extreme temperature, cycling testing, putting in through a test we call MEOS, where we go into vibration, humidity, voltage cycling, all these things at the same time. So the whole important thing is that we cycle those inverters as hard as we can to find the weak points within the inverter so we can fix them now. And on top of that, so that's kind of in the development process. So we take all those learnings during the development, fix the inverter, so our best bet is that inverter is going to last during the whole time. We also do a lot of extensive analysis of anything that fails in the field, and we try to evaluate the failures, and we look for the root cause, and we fix those and put those corrective actions back into production, and then we make sure that those going forward won't have those problems. So it's really a continuous feedback from all the learnings that we've had over the many years of building inverters, as well as the many years we get producing the certain inverters that we have in production.
Yeah, I have to second that as well. Kaco was founded in 1914, and they were in the automotive field until World War II, when they started to make, we were making DC to AC microinverters, I guess, for lack of a better word. They were just small power conditioning devices that were plugged into residential applications, so that folks there, after their grid was destroyed in Europe, they were using small micro DC grids, and so Kaco inverters would be plugged into the home or business so that folks could use AC appliances produced elsewhere. And a company's warranty is only really as good as the company itself. You can warranty anything and be gone in 5 years of major money, and what's the homeowner to do, or the business owner? So I think that's a very valid point. And this standard 10-year warranty for California really prompted Kaco to take the approach of providing a standard 10-year warranty across the board for all North American, all of the North American operations. Europe has been following suit. They're now up to 7-year standard for all of the inverters in Europe and now I believe in Asia. So we're really following that we can provide, all of the testing that you just mentioned is something that Kaco has had in place for over a decade now for our photovoltaic lines. And I think that it stands to reason that the quality and reliability of those products is ensured because of those testing procedures, and so we're able to warranty those comfortably, knowing that we'll be able to replace them in 10 years, 15 years,
I think it's good though that they
years.
set that 10-year warranty expectation, because in a startup business, you think you could, startup businesses can expect to fail. And you can't expect to fail in this industry with a 10-year warranty. If you don't have good product, you're going to be out of business.
Yeah, I think it's important also to separate quality from warranty. Warranty is a financial contract. I will make you whole if something fails. And product quality is something else entirely. And I think, the answer to your question, how do you achieve it, is very, very carefully. You achieve it in the design cycle, you achieve it in the manufacturing process, you achieve it in making sure that it's easy to install. So I think we tend to maybe be a little bit more conservative when it comes to releasing products on the market, because we have an eye to not only making sure our customers are made whole on a financial contract, but doing our best to make sure that those products last their 20-plus year design cycle.
Yeah, I think you made a good point on designing in quality, and I think that's not only the care you take in the component selection and your engineering, but also how you look at the topology of a solar system. If you look at U.S. residential, generally you'll find a string inverter or an inverter hanging in the garage or on the side of the home in a relatively comfortable environment for thermals and dust and all kinds of other things that affects the long-term reliability of it. I think the most harsh environment for power electronics is actually on the rooftop, between the panel and the roof. It gets hot, squirrels build nests, all kinds of things flow through there, and it's an extremely difficult environment to keep something operating for a long period of time. And so when we first looked at the problem of trying to deliver microinverter type benefits to the residential environment, we viewed that by partitioning it, by putting the minimalistic amount of electronics on the roof where it's extremely harsh, get that down to just a few components, and put all of the inversion capability, continue to leave that in a very comfortable environment where it can last for 10 years and beyond, was the right partitioning. So that's one we chose, and therefore through design, by just putting one or two small components up on the roof and leaving the majority of all your control and monitoring and inversion where it's temperature controlled in the garage is a much better way of approaching it through system design.
I think if you look at when we came out with the microinverter, we came out with a 15-year warranty, and I think people were astounded with the warranty. But the primary benefit of converting energy at a single module is that you're processing a lot less power than a typical central inverter or string inverter. And string inverters and central inverters are notoriously the least reliable component of the overall system. The microinverter, because we're processing low amounts of power, it's all integrated in semiconductors, and these are semiconductors that are being used in the PC industry and the automotive industry, and they're very, very high reliability components. That has given us the confidence that we can support a 15-year warranty, and companies like Siemens, who are chosen to OEM our product, are also standing behind that 15-year warranty. So we've been able to prove that the design warrants that kind of warranty, even though we expect it to last a lot longer.
It's a very good question. When we talk about warranties, the warranty is only as good as the company that's standing behind it. Obviously, the product reliability is a very key part of that. But it's certainly a interesting proposition, since we have very different size companies here with Enphase and Tigo. How do you make that, you as smaller companies, how do you make that value proposition to your customer in the warranty environment, when a company like Schneider can say we've been around for 175 years, and SMA can say we've been building inverters since there were electronics or whatever. How do you compete with that?
I think when we first came out, there was a lot of questions about it. I think like any new technology, you have some of those early adopters, and the early adopters used the technology and found that it had some compelling benefits, and at least in the 2 or 3 years that we've been operating, the reliability has matched what we have put on our spec in terms of calculated MTBF. We have a calculated MTBF of 336 years, right? So now, how does that translate into the actual life of the product? It's not an exact translation, but I think the experience that installers had with the product matched what we've spec'd. And I think as the company has become more and more successful, verging, I said, on 750,000 microinverters installed, there's less and less of a question about whether Enphase is going to be around for the long term. And I think, most recently the OEM announcement with Siemens, just again, it was just another factor that said, this is a company that's going to be around for a long time, and I don't have to worry about who's going to back this warranty.
Right. I think similar to that, warranty as the financial instrument. Right. There are things small companies do to make sure we have the right venture backing, the right insurance, and the right aspects of the financial coverage. So that we obviously do, and I would imagine most companies our size do. What you really look at when you're taking a gamble on new technologies, you look at worst case scenarios and the downside in the worst case scenario. So the worst case scenario is any one of us are gone in 5 years, and the investor's left holding the bag. And again, that's one of the advantages of the topology that we represent, is the investor is still working with SMA, Kaco, Schneider, somebody that they've trusted for years, they understand and they know, and augmenting that solution with Tigo. If, God forbid, we're not here in 5 years, the topology is exactly the same. They turn us off in software or they reroute the cabling, nothing changes. The topology is exactly the way it would have been ordinarily. So the downside risk is very, very low anyway. But clearly that's not our intention. Clearly we believe we'll be here for many years to come, and we've architected a minimalistic, solid product that's warranted towards, since it's on the panel, it's actually warranted to 20 years, because the expectation is that it's matched to the panel.
You mentioned Siemens. They actually OEM'd a product of a company that went out of business. Mm-hmm. And the good news for the customers of that particular product is that the fact was that Siemens, having their name on it, made those people whole. Mm-hmm. So they selected a different inverter, happened to be an SMA inverter, and made that company whole. Mm-hmm. So those kind of value propositions are an important discussion, when you're looking at different products and how that all fits together.
Bill, can I just make a point about quality and warranty
Sure.
in a different segment? We've
Sure.
been focused, I think, in the answers to this question on the residential segment. But
Mhm.
if you switch gears to maybe talking about the utility segment, talking about very large ground mount projects, we have customers who are developing multi-billion-dollar projects. So when you're talking about warranty and quality on projects of that scale, the due diligence that is involved, typically shorthanded as bankability, is extreme. So these are banks and other financing entities that are putting potential suppliers through an incredible gauntlet, and so the factors that come into play in that kind of due diligence, are orders of magnitude larger than what an average homeowner is doing when he is making this very significant but $10,000, $20,000, $30,000 buying decision. So when we look at bankability on the utility scale projects, we've been asked to do things like provide all sorts of financial metrics, cash flow, capital to debt ratios, and other key metrics. And because it's again one of our strengths, because of our financial transparency, that's all there for customers to see. So I just wanted to make the point that at the other end of the spectrum, those same issues of quality and warranty are in effect. Only the risks, the ramifications of a bad decision are much higher.
Sure.
Yeah, can I touch on that more quickly as well? I agree. I'm glad you brought that up because the issue of maintaining these types of systems for the long term is it's of utmost importance. And while you're choosing the inverter partner that you'd like to work with in that context, it is important to make certain that you have access to a reliable maintenance program through the manufacturer if possible. I think that's an ideal scenario, and I think companies like SMA and most likely Schneider, and I'm not sure of your situations, but Kaco for sure, for our Blue Planet and XP series inverters offer, coverage of that nature so that the bankability of the project is not of question, and providing those financial metrics seems to be standard for all of us across the board because these are multi-million to billion-dollar systems that are being developed around the country, and being able to provide that type of financial backing is necessary at this point. Otherwise, these systems are not installed, at least not with our products. So I think that that's an important thing to consider, and to talk to the manufacturer that you're choosing about what type of maintenance options are available, what type of long-term extensions are available for your warranties, and their experience level with those on the local and regional and international scale.
Very good. Well, it's the industry is such a young industry. I think a lot of the focus has been on construction, on building stuff, and what's near and dear to my heart is the operation and maintenance side of things. I've been working around this field, been working on systems that are pushing 30, 40 years old, and you start to see things, obviously, at those kind of ages. And I bought my first system for myself 12 years ago, and I fully expect to retire with it. These are solar panels that I'm going to live with for my entire lifetime, and so how they survive and all is very important to me. And so I think asking those questions about operation and maintenance is very, very important, and how we're going to work on equipment as it ages, what kinds of things would have to be replaced, how would they be repaired. All those things are very important issues, and I think so. We only have a few minutes left here, and so I guess to allow our panelists to kind of give a final send-off here. Here you are, let's say you're across the table from a building owner or a homeowner that's wanting to purchase some electronics for their PV system. In 30 seconds, what information would you like to get across from your company and the values of your company that would make them want to decide to purchase your product?
Yeah, the summary is always tough, but I would just say that I'm more than anything else at SMA. All of my colleagues share the belief that we are proponents of the industry and big fans of helping everybody succeed. Because if any one of us at this table gets a black eye, it's a black eye for the industry. At the end of the day, I think that the key message for the average homeowner or the average business owner is that with the current suite of incentives in play today, we are essentially at grid parity. So the decision of whether to proceed with the PV system or not is simply a financing decision. There are all sorts of innovative business models. Our customers are bringing them to the market every day, from the residential scale to the commercial scale. I think what we've found, at least in our experience, is that unlike the consumer world of electronics and gadgets, what pays at the end of the day in PV is old reliable. People like old reliable. It's kind of like the airline pilot. He's most comfortable with old reliable. So that's why customers use us.
Mike, what do you say?
Hey, well, for Schneider Electric, Square D, APC, those name brands bring home to all of our customers high quality. So we are determined to maintain that reputation for high quality. We plan to completely stay focused for our group within renewable energies business, and it's really from those modules out to where it goes back on the utility. So our customers, whether they're residential, commercial, or the utility guys, we're going to be in those systems and on there supporting them for the remainder of time.
Bill?
So I would say most of our customers today, a good majority are homeowners or residential, and there it's all about like put something on your roof that's going to give you the most amount of energy and last the longest amount of time, and you can monitor it, right? You can see it. So that's primarily our pitch.
I concur. I think at Kaco we want folks to understand that they need to take a moment to investigate the company that they're going to choose when they pick an inverter, and it's important to make certain that the company they choose has a history they can rely on, has a product that they want to have hanging on the side of their house for the next 20 years, and that will be backed up by the strength of the team that supports it. I think that's one of the most important considerations when you're buying a system that's supposed to be on your roof for 25 years.
Jeff?
And so I agree with Bates. There's no other investment that I can think of that has double-digit returns the way solar does in most states in the U.S. with the safety and security that the investment would have. It's an amazing way to put money to use, and I think the consumer across the United States should really look at that as a way to do good by the environment, but also a great investment. And when they make that investment, we would encourage them to add the little Tigo on the module, just so they can see the value of that investment over the next 25 years and make sure that it's working well for the whole time.
Great. Well, thanks everybody. I appreciate the panelists taking their time, and hopefully this has been valuable for the people watching. They learned a lot today, and hopefully you'll go into a buying decision with a lot more information. Thanks, and have a great day.
Thanks, Bill.
Thanks, Bill.
Thanks.